Today, we are playing around with the zeros and ones, determining the longest length of concatenations of consecutive substrings in an array. We are building buildings with a pile of cubes. We are detecting pangrams. And then we are determining human-readable durations. Hello world, and this is episode number 20 of vs. Codewars. We begin today with the warm-up segment, a series of easier katas to prepare for the more difficult katas later on in the episode. Starting with a function that takes an array of numbers, squares each element, and then adds them together to produce the final result. Let's go ahead and get started with this one. Our function signature is going to look like this. Const square sum. It takes our numbers array right here. And what this function is going to do, we are going to take numbers and run it through the reduce method. We're going to have our accumulator and our value, and we're going to return our accumulator plus value times value. That is the value squared. All right, let's go ahead and punch this into Codewars and see what that looks like. We are good on that. Alright, our next warm-up kata, we are counting sheep. Given an array of booleans with trues representing our sheep, we need to count the number of sheep present in the array. Let's go ahead and get started with this one. And the kata instructions also mention not to forget to check for bad values like null and undefined. Our function signature here is const count sheeps. And it takes our array of sheep as an argument. And what we'll go ahead and do is we're going to take that array of sheep and we're going to run that through the filter method. It's going to take our sheep as a predicate, and our predicate function is going to take our sheep as a parameter. And what we're going to do here, we're going to try this. Double exclamation point sheep. You saw this in a previous kata on vs. Codewars here. This is the double exclamation point here. It's two unary negation operators. A nice little trick that can be used in JavaScript and probably other programming languages as well in order to coerce any kind of value into a boolean. What we want to do is take this sheep, use this little trick, and see if it coerces this to true. And in so doing, this should coerce bad values like null and undefined to false, and thereby filter those out. Let's go ahead and feed this into Codewars and see what that looks like. And what's going on now? Because we actually need to get the length of the resulting array. Let's do that again. Let's try that again here. And we are good on that. For our next warm-up kata, we are checking to see which century the given year falls into. Let me save this here. Let's go ahead and give this a go here. Our function signature is century, and it takes our year as a parameter. What we're going to go ahead and try to do here is, it says in the kata, for the sake of this kata instruction, a year, the century, starts at x1. So, for example, the 19th century starts at 1801 and ends at 1900. The 17th century starts at 1601 and ends in 1700. So what we're going to go ahead and try to do here is, we're going to keep track of a couple things here. Let current year, we're going to set that to 1. And let current century equal 1. And what we're going to go ahead and do, while current year is less than or equal to year, what we passed in here. We're going to do current century plus plus, and current year plus equals 100. And then this should cause us to break out of the while loop once current year exceeds the year passed in. What we'll do is return current century. All right, let's go ahead and test this out here. Console.log century. Let's try passing in 1601. Speed this in a node and see what that looks like here. Warm up century. Century is not defined because we misspelled century. Let's try that again here. Current century is not defined because, again, we misspelled century. Twice, actually. Let's try that again, and we get 18. We actually do not want that. Maybe if we set current century to 0, actually. And we do get 17. Let's try 2000. We get 20. Let's go ahead and punch this into Codewars and see what that looks like. Give this the old try here. And we are good on that. Our next warm-up kata, we are given an array of 1s and 0s. And our goal here is to convert that array into an equivalent binary value of an integer. Alright, let's go ahead and give this a shot here. Const binary array to number. It takes our array of 1s and 0s here. And what we're going to go ahead and do is we're going to keep track of an exponent here. Let exponent equal 1. And what we're going to do here is return array.reduce and value what we'll do at the end of this, we'll increment our exponent here. If the value is 0, we'll keep track of our result here. Or rather, if value is set to 1, we'll do result plus equals math.pow 2 to the power of exponent. Alright, let's go ahead and give this a test run, shall we? Console.log binary array to number, and we'll pass in this array right here. Alright, node warm up 1s and 0s, and we get 30. We do not want that because exponent needs to be 0. And we get 15 like we were expecting. Let's try 1 0 1 1. We get 13 and we do not want that. What is going on here? Because we need to reverse it. Let's try that. Yep, we get 11. Let's try another array here. 0 1 1 0. This should give us 6, and it does. Let's go ahead and punch this into Codewars and see what that looks like. And we are good on that. Finally, we are checking to see if 3 integer values sum up to a let's try that again. Finally, we are checking to see if 3 integer values representing the sides of a triangle can be made into a triangle. Let's try that again. We are implementing a function that takes 3 integer values, and the goal of this kata is to return true if a triangle can be built with the sides of the given length, and false if not. Alright, let's go ahead and try this here. Const is triangle equals A, B, C. Now, the general rule of this is that the sides can be made into a triangle if the sum of any 2 sides is greater than the third. So what we'll go ahead and try doing here is we're going to make these into an array and sort them in D or ascending order. Const SA, SB, and SC equals ABC dot sort. We're going to console.log that and see what that looks like. And we're going to go down here, do console.log is triangle. Let's see. Let's pull up one of our test cases here. 7, 2, and 2. There, warm up is triangle. Let me get our 2, 2, and a 7. Alright, what we'll go ahead and do with that is return true if SA plus SB is greater than or equal to SC. And that should give us false. This should give us true. Let's punch this into Codewars and see what that looks like here. And we got a problem here. What's going on? Test for oh. Okay, looks like we are testing for negative values here. Alright, let's go ahead and run these through console.log and see what's going wrong here. SA, SB, SC. To attempt here. Okay. This can't be, this can't even be equal to, it's got to be greater than then. Alright, let's try that again. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. During our warm-up segment, we were working with 1s and 0s. Now, we are working with 0s and 1s. Given an array of 0s and 1s, the goal of this kata is to seek out the index of a 0 in the array, such that changing that 0 to a 1 results in the longest sequence of 1s in the array. Let's go ahead and give this a try here. First, I think what we'll do is try to get the indices of each 0 in our array, and we can do that with the reduce method. Const 0 indices equals arr.reduce. We're going to have our 0s and the element. And we will need the index of the array here as well. And for our initial accumulator, we'll have an empty array here. What we'll go ahead and do is, if element is equal to 0, then we'll return a spread of our zeros array and the index of the current element of the array. Otherwise, we'll just go ahead and return our zeros. So what we're doing here, we're using the reduce method to find out the index of all of the zeros in the array that was passed in. In our predicate function, we have our accumulator, which will be an array containing the indices of each zero in the array, the element that is currently being worked on in the array passed in, and this third argument introduces predicate function, which is the index of the current element of the array being worked on. We will need this for our return here, because if the current element is 0, we want to push this index into our 0 indices array. Let's go ahead and console.log that and see what that looks like. Alright, I am going to grab this array here from our Kata instructions here, and I'm going to go ahead and console.log replace 0. We're going to pass in that array right here. Let's go ahead and punch this into node and see what that looks like. Node zeros and ones. And we get the index. We get the indices of each 0 in our array. 1, index 1, remember arrays are base 0. Index 5, index 10, index 15, and index 16. Alright, what I think we'll go ahead and try doing from here is...
Alright.
For let I equals 0, I is less than 0 indices length plus I think. What I'm aiming to do here is what we'll try doing here is const previous 0 is 0 indices and I minus 1 or 0, and const next 0 is equal to 0 indices I plus 1 or 0. I'm going to feed this in a node and see if node yells at me for that. Apparently not. So what I think we'll go ahead and do here is maybe if I make this into a minus 1 and I make this into 0 indices dot length. What I think we'll go ahead and try doing here is or maybe it is 0 here. Console.log next to 0 minus previous 0. Maybe it is minus 1. Alright, maybe 0. Alright, I have another idea. If I is equal to 0, then alright, we'll go ahead and keep base 1. Alright, let's try something else here. Alright, I'll go ahead and reset here. What we got here is our array of 0 indices here. And 1, 5, 10, 15, and 16. 5, 4, 3, 2, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Alright, what I think we'll go ahead and try doing here. For let I equals 0, I is less than 0, indices dot length plus I. First, get the distance from this index to the previous 0 or to the beginning of the array. Alright, previous 0, next 0. Now, if we're at the beginning of the array, I have another idea. Let previous length next left length and right length. Alright, so left length will be the distance to the position of the 0 before this 0 or the beginning of the array. And right length measures the number of ones between this element and the next 0 in the array or the end of the array. So left length equals, if I is 0, indices at I or say 6, 5, 4, 3, 5, 4, 3, 2, 1. 0 indices at I minus 0 indices at I minus 1 minus 1. And then right length is equal to, if I is equal to 0 indices dot length minus 1, then 0 16, 17, 18. So 0 indices dot length minus 0 indices at index I Alright, let's see if I have my math right here. Yeah, either that or... zero indices and I plus 1 minus 0 indices and I think minus 1. Let's go ahead and console.log these and see what these look like. And we have 1 and 3, 3 and 4, 4 and 4, 4 and 0, and 0, and this is not right. And that would be because we want the array.length and not the 0 indices.length. That still isn't right, so we need to do minus 1 as well. 0 and 2. Alright, we're going to go ahead and keep track of a maximum length. Let max length equals minus 1. Alright, we're going to go ahead and const concatenated length, and we're going to do left length plus right length. If and we're going to go ahead and do that plus 1 here. If concatenated length is greater than max length, we're going to go ahead and reset our max length to the new concatenated length. And then at the end of this function, we'll go ahead and return our max length. Alright, so what we're trying to do here is, in this for loop here, we're iterating from 0 to the length of our 0 indices array that we generated up here. We have two variables here, left length and right length, which represents the number of ones on either side of the 0 at the given index of the array. What we're doing here, we're setting the left length to either the value of the current index of the 0 indices array if our I variable here in our for loop is set to 0. Otherwise, we're setting the left length to the index of the 0 indices array at index I, and then the index of the 0 indices element of the 0 indices array at index I minus 1, and then we're subtracting 1 from there. Likewise, we get the number of ones to the right of this index to the next 0 by taking this right length, and if I is set to the length of the 0 indices array minus 1, which means we're at the end of the array, we set it to the length of the array that we pass in up here, minus the index of minus the element of the 0 indices array at index I, and then minus 1. Otherwise, we're taking the element of the 0 indices array index I plus 1 and subtracting the element of 0 indices at index I and minus 1. That way we know how many ones are to the left and to the right of the 0 at the index of this array, which is mapped to the element of our 0 indices array at index I. Next, we concatenate those lengths, adding them together and adding 1 to represent the current 0 here to get our concatenated length. We keep track of the maximum length in this variable right here. setting it if this is greater than this. And then at the end of this function here, we return the max length. Let's go ahead and punch this into Node and see what that looks like. And it gives us 9. We actually need the index, though. Okay, yeah, okay. Let max index equals -1. And max index equals I. And we'll return the max index. And that is not right either. Because we actually need the 0 in this index here. And let's try that again, and we get 10 for index 10. Alright, let's try some of these other tests here, shall we? How about this 0, 1, 1, 1 here? Feed that in the node, and we get index 0. Let's try some other arrays here. I expect to see 6, and we do. Then again, that might be acceptable too, because if there are multiple results, return the last one. Stick an equal sign here. And we do get our 6 here. Alright, let's try another array here. One, 1, 0, 1, 1, 0, 1, 1. We get our 5. I think we are good to go here. Let's go ahead and punch this into Codewars and see what that looks like. Do we get yelled at here? We do not get yelled at here. We are good. Here is the clever code solution of the day. Pay mind to the code snippet you see to your right here. And pay mind to the very clever use of the reduce method here. Alright, here's what's going on. We have our array that we passed in here. We join it together into a string using a blank space separator. We split the resulting string using 0 as a separator, and then we take the resulting array of strings and run it through the reduce method. Note the 5th parameter in the reduce method's predicate function. Although normally the predicate function only takes a maximum of 4 parameters, apparently JavaScript won't yell at you if you include a 5th. In this case, a default parameter, which points to the string at the next index of the resulting array. Alright, our other 4 parameters here is the accumulator, which is result, an array, which is the element currently being worked on in that array, and then our index and our array parameters, which are apparently not being used here. Now, pay attention to what you see in the body of the predicate function here. If our 1's right, which is that 5th parameter you see here, is not undefined, what we do, we take the current length variable that we track here, and we set that to the length of the current substring that we are working on. Add the length of the next substring if it's defined, and then add 1. We take an index, which is being tracked above the reduce method call here, and we set that to the current substring's length plus 1. We add the current substring's length plus 1. And then if this maximum length is less than or equal to the current length, we keep track of the maximum length up at the top of the function here. We set that to the current length, and then we set a result which is our accumulator to the index that we set above, -1. We keep repeating this until the one's right substring is undefined. And that's how we get to the index of the 0, such that changing it to a 1 results in the longest sequence of 1s in the array. Given an array of strings and a positive integer, the goal of this kata is to return the first longest combination of that number of consecutive strings in the array. Let's go ahead and give this one a try here. Alright, what I think we'll do is we'll keep track of our maximum length here. And we'll keep track of our maximum string here. And what we'll do is, for let I equal 0, I is less than strar length plus I. And what we'll go ahead and do is maximum. We'll go ahead and keep track of a current concat here too. Current concat equals strarr dot slice from I to I plus k. And then we'll join that together with a blank string separator here. And if current concat dot length is greater than maximum length, what we'll go ahead and do is set maximum length to current concat dot length, and then we'll set our maximum concat to our current concat. And then from there, we can go ahead and return our maximum concat. So what we're doing here, we're keeping track of the maximum length of our concatenated strings. We're keeping track of the current concatenated string that is of the longest length in our array here. And then we're also keeping track of the current concatenated string, which is the concatenated string starting at the current index and going k length here. Now, in our for loop here, we have for let I equals 0. We start at the beginning of the array, and we go to the end. We take the current word in our string array, and we concatenate the next few words according to our k parameter here by slicing the array starting at I and then going to I plus k. We take that sliced array and we join it together using a blank string separator. We then calculate the length of the resulting string, and if it's greater than the currently tracked maximum length, we set a new maximum length to the length of this concatenated string. We also keep track of the maximum concatenated string, setting that to current concat. At the end of this loop, we return maximum concat. Alright, let's tackle some edge cases up here. If strarr is .length is 0 or k is less than or equal to 0, return a blank string. Alright, let's go ahead and test this out on some tests here. Let's go ahead and punch this into Codewars actually and see what that looks like. Let's run these tests here. And we have a problem here. Oh, that's interesting. Alright, let's go ahead and console.log our string array and our k here. and debug the issue. Oh, this one here. Okay, what we'll do here then is if k is greater than str_ar.length, then we'll also return a blank string in that case. Let's go ahead and try that. Let's hit attempt. And we are good. Not really much to say about this one. However, I probably did not need to keep track of the maximum string length here. The maximum concat and current concat strings were doing that just fine with the .length property. Also, normally, the string objects and array objects slice method would take two parameters, the start point and the end point. However, what if you wanted to give it how many elements or characters you wanted to slice from that string or array? Try passing in the start point as the first argument, and then the start point plus the number of characters or elements you want sliced for the second parameter. You are given the volume, M, of a building. The goal of this kata is to build a building with that volume using a pile of a number of cubes n, such that the volume of the bottommost cube is n cubed. The cube above that has a volume of n-1 to the third power, and so on, all the way until the topmost cube, which has a volume of 1 to the third power. If no such building can be built, we return -1. Let's go ahead and get started with this here. Alright, what we'll go ahead and do is, we're going to go ahead and keep track of the number of cubes. Cube count equals 0. And we'll keep track of a building volume. We'll set that to 0 for now. And while building volume is less than m, which is the volume of the building we want built, what we'll do is building volume plus equals. We're going to use the math.pow method, and we're going to do a pre-increment operation on cube count. So cube count will be incremented first before this function is run, and we'll raise the result of that to the third power. Alright, what we'll go ahead and do from here is we're going to return if building volume is equal to m, then we return the cube count. Otherwise, we return -1. Let's go ahead and test this function out here. Console.log, find NB, and we'll pass in this value here, 1,071,225. Let's go ahead and run this through Node and see what that looks like. Node pile of cubes, and we get 45. What about this gargantuan looking value here? What is that? 1, 2, 3 billion trillion. Looks like we have here 91 quadrillion, 716 trillion, 553 billion. No. Scratch that. This is 91 trillion, 716 billion, 553 million, 919,377. Let's test this out here, and we get -1 because we cannot build a building of exactly this volume with the cubes that we are given here. All right, let's run some other tests here. Use some more peculiarly long looking numbers. Yeah, here we have 1,000 million billion 4,183,059,834,009. We need 2,022 cubes to build that. What about this one here? I think this is 24,723,578,342,962. We should get -1 from that because we cannot build a building of that volume using the cubes we are given. What about to this one here? This, I believe, is 135,440,716,410,000. Right on the nose. This gives us, this building can be built using 4,824 cubes. And finally here we have 40,539,911,473,216. And that building can be built using 3,568 cubes. Alright, let's run this through Codewars and see what that looks like here. Run through our tests here. And we are good. There is another way to implement this solution that does not use the math.pow function. More recent versions of JavaScript now include what's known as the exponent arithmetic operator, denoted by 2 asterisks, where if you use n, then those 2 asterisks, and then 3 after that, that resulting operation will return n to the power of 3. A pangram is a sentence that contains every single letter of the alphabet at least once, regardless of casing. Given a string, the goal of this kata is to check to see if that string is a pangram. Let's go ahead and get started with this one. What I think we'll do is, let's try doing something like this. Const letters only equals str.replace. We'll use a regular expression here that checks for anything that is not a letter, and we'll replace that with a blank string. Let's console.log that and see what that looks like. We're going to do console.log is Pangram. I'm going to pass in the classic, the quick brown fox jumps over the lazy dog. Alright, let's feed that in a node and see what that looks like here. Node Pangrams. Replace all of them. Yep. And we get our string with only letters. Alright, we're going to change that to lowercase here. And what we're going to do with that is we're going to do a letters set. We're going to set that to a new set, passing in an array of that string's characters, letter characters. I don't know if set has the .length property here. Let's see what that looks like. Nope, does not seem to have that here, but it does have size. Alright, let's go ahead and return true if letter set.size is equal to 26. Because obviously there are 26 letters in the English alphabet. Let's go ahead and punch this into Codewars and see what that looks like. And we have a problem. What's going on? Alright, let's go ahead and let's log that in. Huh. Yeah, looks like our regular expression is catching numbers here. I was not expecting that. Alright, what we'll go ahead and do then is run another replace here. And we're going to get rid of the digits as well. Or we're going to go ahead and feed that into Codewars and see what that looks like. Run the tests. And we are good. Another way I could have done this was to take every letter of the alphabet, place it into a string, and then spread that out into an array with the spread operator. I would have taken the resulting array and run it through the array object's every method. And in the predicate function, I would take each letter of that array and check to see if a lowercase form of the string passed in to the Kata solution would include that letter in the alphabet. The array object's every method returns true if all calls to the predicate function passed in return true for each element of the array that every is being called upon. Given a positive integer representing a number of seconds, the goal of this kata is to calculate a human-readable duration, expressed as a combination of years, days, hours, minutes, and seconds, in that order. Let's go ahead and give this one a crack, shall we? First, let's go ahead and set up some constants here. Const seconds per year. Yeah, it's const seconds per. We're going to set that up in an object of some constants here. Year. It's going to be 60 seconds to a minute times 60 minutes to an hour times 24 hours to a day times 365 days to a year. Day. It's going to be 60 seconds per minute times 60 minutes per hour times 24 seconds to the day. Hour. 60 times 60. And then minute. Alright, we're going to go ahead and set up an array here. Const durations 0, 0, 0, 0, 0. All right, this array here will contain our durations in each of these metrics here: years, days, hours, minutes, and seconds. All right, we'll go ahead and keep track of our seconds remaining here. And what we'll go ahead and do is, actually go ahead and set that to seconds here. while seconds remaining is greater than 0. And what we'll go ahead and do is if seconds remaining is greater than or equal to seconds per dot year, we'll do seconds remaining minus equals seconds per dot year. And then we'll do durations at index 0, which represents the number of years, plus plus. Alright, else if seconds remaining is greater than or equal to seconds per dot day. We'll do likewise here with our day here. And that's index 1 of our durations array here. Else if seconds remaining is greater than or equal to seconds per dot hour, we'll do our hour here instead. And hours will be the third index of our durations array here. Then else if seconds remaining is greater than or equal to seconds per dot day or minutes. Seconds remaining equal. These should be minus equals here. Minus equals seconds per minute. Durations at in element index 3 plus plus. And else seconds remaining equals 0. And then durations at 4 is equal to seconds remaining. And with that, we should have the number of years, days, hours, minutes, and seconds here. Let's go ahead and console.log that and see what this all looks like here. Console.log durations. All right, let's go ahead and down here we'll do console.log format duration. Let's pass in 3662 here. All right, speed that into Node and see what that looks like here. Node human-readable duration. And we should have 0, 0, 1, 1, 2. And that is not right. Alright, let's go ahead and see what's going wrong here. Console.log, seconds remaining. 62. Actually, I was looking at the wrong line here. That is right. Yeah, I was looking at the wrong line in the Kata instructions examples here. What I have here is right. We have 1 hour, 1 minute, and 2 seconds. Oh, let's go into... Let's pass something a little bit more exorbitant in here. 987654321987654. Let's see how long it takes for this to go through here. Yeah, that's quite some time here. Let's try getting the Unix epoch here. time since the Unix epoch here at date.now. Yeah, that does not seem right here. Because that's milliseconds, Dennis. Let's try dividing that by 1,000 here. Math that, floor that. Yeah, that seems more like it here. Alright, what we'll go ahead and do, we now need to we now have the information we need here. We now need to convert that into a human-readable format. What we'll go ahead and do from here is we'll calculate our results string here. Is that human-readable? And what we'll do here is we're going to destructure our years, days, hours, minutes, and seconds here. And we'll do that by doing this. Const years, days, hours, minutes, and seconds. And we'll pull all that from our durations array here. So if years is greater than 0, then oh, right, okay. All right. Oh, I have an idea here. Let human readable durations set that to a blank array. Or rather, durations dot map. I think we'll go ahead and do I think we'll do a parallel array here. Const duration measures year, day, hour, minute, and second. If duration is 0, then we'll make this return a blank string. We will need the index in this predicate function here. Otherwise, return duration, then depending on whether duration is 1 or greater than 1, we'll do this. Duration measures at index, or duration measures at index with an S at the end. Let's go ahead and console.log that and see what that looks like here. I think that looks good so far. What we'll go ahead and do now is return in a template literal string here human readable durations dot slice from 0 to, or rather -1 here. Let's console.log that and see what that looks like here. 1 to 0 to -1 here. Dot join with a comma and a space. And then, and human readable durations dot slice -1. 51 years, 325 days, 18 hours, 44 minutes, and 54 seconds. I think this is the solution we are looking for here. Alright, let's recap what's going on here. First, we have this object here containing some constants as to how many seconds go into what measure of time. We have 60 times 60 times 24 times 365 seconds to a year, 60 times 60 times 24 seconds to a day, 60 times 60 seconds to an hour, and 60 seconds to a minute. We have a constant array here containing each of our duration measures here. The ordering here is important. We have year, day, hour, minute, and second. We then have an array of parallel length containing each of our durations here. First the number of years, then the number of days, then the number of hours, then the number of minutes, and then the number of seconds. We then keep track of the remaining seconds here for the while loop coming up here, and we initially set it to the number of seconds passed in. Then, in this while loop, which continues as long as the number of seconds remaining is greater than 0, we check to see, respectively, if the number of seconds remaining is greater than the number of seconds in a year, then a day, then an hour, and then a minute. And then the first instance of seconds remaining being greater than or equal to any of these metrics here, we take the seconds remaining and subtract the number of seconds in that metric. And then we set the specific index of our durations array, and we increment that by 1. So index 0 is the year, index 1 is the day, index 2 is the hour, and index 3 is the minute. If the seconds remaining is less than the number of seconds in a minute, we take the durations array at index 4, which is our seconds, and we set it to seconds remaining, and then we set seconds remaining to 0. We might actually be able to break out of that for loop here. We set the seconds remaining to 0. so we can break out of this while loop here. Next, we take the resulting durations array, and then we run it through the map method. In its predicate function, we have the duration metric, year, day, hour, minute, or second, and then the index of that array being worked on. The ordering is important here. Alright, if the duration is 0, we just return a blank string. Otherwise, we take that duration, we return it in a template string, and then, depending on whether the duration is 1 or greater, we do the that particular index in the duration measures array, and if it's greater than 1, we append an S to that. So, for example, if the index was 0, we'd be working with years. So we have the duration, and then either year if duration is 1, or years if duration is greater than 1. And we have that blank string here if duration is 0. Alright, we then, in the return value here, we return a template literal string here. We have our human-readable durations here, this array right here. We slice from 0 to the second to last element of that array, indicated by the -1 here. And then we join that resulting array together with a comma and a space. And then we have and human-readable durations, we slice the last element of that array out here. Alright, I have this console.log right here with a call to format duration, which takes the floor of date.now, which calculates the number of milliseconds since the Unix epoch way back in January of 1970, and divide that by 1000 to get the number of seconds. Running that through Node, that gets us the result of, at the time of calling this function here, 51 years, 325 days, 18 hours, 49 minutes, and 45 seconds. Let's run this through some other tests here and see if they are sound with this. Let's try one. And I can tell we have a problem with that. A problem which can potentially be remediated by by filtering out any blank strings here. And finally, if human-readable durations.length is 1, we just go ahead and return that lone metric here. We have 1 second. Let's try 62 here. We have 1 minute and 2 seconds. Let's try 120, which is exactly 2 minutes. We have exactly 2 minutes. Let's try 3600, which is the number of seconds in an hour. Let's try 3662. 1 hour, 1 minute, 2 seconds. Let's try 86,400, which is the number of seconds in a day. We have 1 day. And let's try 60 times 60 times 24 times 365, which should be the number of seconds in a year. Yep. Let's multiply that 30. Let's see if we get 30 years out of that. And we do, in fact. This being a 4Q kata, I imagine optimization is probably going to need to be a must. But first, let's punch this into Codewars and see what this current solution looks like here. Let's run the tests. Let's hit attempt. And sure enough, we've got a problem here. Yep. First, let's go ahead and get rid of this console.log here. It's not needed. I forgot about the now here. If seconds is 0, return now. Alright, let's take all of this, feed this into Codewars, and see what that looks like. And we are good. Here is another better code solution of the day. Pay mind to the code snippet you see below me here, particularly the object at the top, which keeps track of the number of seconds in each of our time metrics in order of year, day, hour, minute, and second, and the human-readable durations array below that here, as well as the for loop here, which iterates over each of the keys of that object. For each key of that object, which represents a time metric, we check to see if the number of seconds is greater than or equal to the number of seconds in that time metric. If it is, we get the quotient of, the floored quotient of the number of seconds remaining divided by the number of seconds in that time metric. And we also get the remainder of that later on. Alright, we push into the human-readable durations array that number of that time metric, years, days, hours, etc. And then if that number is 1, we push in 1 and then the key, that time metric here, for example, 1 year. Or if that value is greater than, if that quotient is greater than 1, we push in that quotient space and then the number, the time metric here with an S at the end. For example, if that floored quotient is 5, we put in 5 years, for example here. And then we take the remainder of seconds remaining divided by the number of seconds in the time metric, and we set that as the new seconds remaining for the next iteration of that for loop. And then from there, we can just go ahead and do what I did with the Kata solution. It's probably a little more understandable than what you see with the regular expression down here. There is nothing like ending an episode off by solving a 4Q Kata. That's going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.